Here I have a electronic LED converter which was doing the lights in the kitchen. Decided last night to go bang. I've removed the outer covers to remove the cables. So we'll have a look, see what we've got inside. Well, the circuit board fell off. Have a look. Turn that over, down. Oh dear. I think we had a little bit of an explosion. And chip. There's the top of the chip. I've had one of these before, not explode but stop working. And I'd bought a couple of these, so I've got one spare. So what I need to do now is clean it up with IPA, desolder that chip, make sure that the bridge rectifier is okay, that diode there is okay, and probably the optical was it, and check the capacitor. And if the capacitor's gone, game over. And it looks like there's a fuse here which is also blown. So we'll have to try it, just diagnose it bit by bit. I'll turn that over. Multimeter. Continuity. It doesn't. It's not very loud. Right. So yeah, that's definitely gone. Right. So we go to the other side. But we haven't got a short. There's the rectifier. Let's have a look there. Oh, put it in diode mode. Yeah, we might have that diode between there and there gone because it's showing 0 volts. That one is 0.437. There. 0 volts. 0.46. I'll cross those two. 0.43. Other way. 0.43. 0.43. 0.43. I think we need to take that out and just double check it. See how things are with it. We need to remove the chip and the bridge rectifier, and obviously get rid of the fuse. It's gone. See what size fuse it is. I haven't got any, so it's not going to be a top. Right, it's a 2 amp 250 volt, and according to the cover it's 15 watts output at 24 volts. So let's get started. Right, we'll start to clean up, put a bit of IPA on it, see what we get. That resistor looked a little bit black. And that, and the choke was covered. That's cleaned up a little bit. Well, the resistor looks okay. It looks like a 680k. Meter in a place I can read it. Yeah, 680. It reads 669.9. So 67. The reading. Right, next step. Remove the components. Desoldering gun on. Device on the back. That one is an LM431, which is a adjustable precision Zener diode. I haven't got anything in that package. I've got the ordinary 3-pin transistor type package. So if that's gone, change that. Just lay the thing down flat. I think there might be enough room under the board, but as I say, we need to desolder the chip and the bridge rectifier. Right, I think the first job in removing these is to get the soldering iron and add some solder to these components before attempting to remove. Then we got such a heat sink this side, it's not too bad getting this off. Extra solder on. We can use the machine, and then we'll take this out just to double check that it's okay. That's that bit done. And now for the threaded machine. Not done properly. Now for the bridge rectifier. Getting old. Shake your hands. I think he was coming out. Yeah, he come out. So, lovely. Let's see if we can get the broken one out. Broken thing. Reach up and put that back up there. And we'll get the screwdriver, see if this thing will move. Yep. And we have holes in the board. So That's the old device. Right. About testing this. I can. On the AC. Short. Positive. That side. Nothing. Short. Yeah, so that is a dodo. So I need to replace that as well. I forgot to take out the fuse as well. Let's do that. And everything over. Let's get a better setup. Instead of being in a cramped corner. That should come out. Back. See. There we are. One defunct fuse. The only thing I can do there is I think I've got a 20 mil 2 amp fuse. There might be room to put it in. Go from there. Right. Those bits. Need to test the diode, the LM31. Get it right. Need to check the optic isolator. Test the LED side of the opto isolator with the homebrew diode tester. Fingers out of the way. There's 6.3. Try the other way. 1.22. So I expect that will be okay. Can't see why not. Just try it on this. Yep. This is the end. Yep, short. So that's it. Definitely kaput. As you can see, the The chip was a TMY 280PN. I have one in stock which I changed, and I'm going to purchase some more to have in stock, because I've got about 3 or 4 of these converters, LED converters, above the unit, doing various lights, just in case the others start to go. Here we have the data sheet for the TMY 280 family. There's this typical circuit diagram of it, and there's your device. As you can see, the TMY 280 has a 36.5 watt continuous or peak output, and a bit of data there about enclosures without any ventilation, so you're talking about 20 watts. I know for a fact that the LEDs out there only come up about 10 watts total. That is the typical diagram of the Tiny Switch 3. And there's the LM431. I have a new bridge rectifier, so let's get that soldered in. Then we'll try the main IC. Got some fuses on order going here, so that's in. Now we'll get the new IC and try that. New IC, drop it in. Only go one way because it's four legs on one side and only 3 on the other. See, also you've got the ident on the chip and also on the board. So let's get that one soldered in. Check for shorts on the output of device. There is no shorts across there. Diode's okay, capacitor's okay. Check that capacitor, that's okay, they're okay. The only one I didn't do was that diode down in the bottom there. I need to check that, because that's probably from the snubber circuit. It's the multimeter for this one. Yep, that's fine. Put a short across where the fuse is. I cannot find the fuses at the moment. I've ordered the correct fuse for there, so I'm going to use the light bulb tester. So we'll switch that on. Lamps in circuit. Take the lamp out. The LED goes out. So that's in circuit. Right, we'll switch it on. Well, there's no bang. Get the voltage. Got DC. And put that wrong way around. That we have 24 volts on the output. So everything's working okay. So before I can put this back into service, I need to get that fuse. Get those fuses ordered and installed. That means I can then put this back, and the kitchen lighting, LED lighting over the cupboards will then work.